The aim of this experiment is to find the height of the room by using a bouncing ball. I've changed the experiment slightly because of the camera angles, and I'm going to do the height of the ceiling above this table. So first of all, I want to find the coefficient of restitution between the ball and the table, and I'm going to do that by dropping the ball from a height of 1 metre. And the ball rebounds to a height of almost 80 centimetres. First, we will use the downward motion of the ball to find the impact speed, which I'm going to call V1. We'll use the equation v squared equals u squared plus 2as. In this case, V1 is the value of v, this is what we're trying to find. U will be 0 because the ball is dropped from rest. A will be 9.8 because the ball is falling under gravity, and S will be the distance of 1 metre. That gives us V1 equal to 4.43 metres per second. Next, we will calculate the rebound speed, which we'll call V2. This is the speed at which the ball leaves the table after the bounce. Again, using v squared equals u squared plus 2as. V will be 0 because the ball is moving upwards and its final speed will be 0. U is what we're trying to find, so that will be v2 squared. But this time, because the acceleration and the displacement are in opposite directions, we need to use minus 9.8 for the acceleration, and we know that the distance is 0.8. Solving this gives us V2 equal to 3.96 meters per second. We can now use the impact speed and the rebound speed to calculate the coefficient of restitution, which we will call E. E is equal to the rebound speed, V2, over the impact speed, V1, which in this case is 3.96 over 4.43, which gives us a value of 0.89. I'm now going to drop the ball from the ceiling and again look for the rebound height. So the rebound height is just under 130 centimetres. We will now calculate the rebound speed for this second bounce, which we will call V3. Again, using v squared equals u squared plus 2as. The ball is moving upwards, so in this case v will be equal to 0 because the ball comes to rest at its highest point. U will be the rebound speed at the table, which is v3 squared plus 2 times, and again minus 9.8 because the acceleration and the displacement are in opposite directions, times the height, which we know is 1.3. This gives us v3 equal to 5.05 meters per second. Now, by considering the bounce and using the coefficient of restitution, we can calculate the impact speed, the speed at which the ball hit the table. We'll call this V4. We will do this using the coefficient of restitution. E will be equal to the rebound speed, V3, divided by the impact speed, V4. E we know is 0.89. V3 we know is 5.05. That's the rebound speed, and V4 is what we are trying to find. So V4 from this will be equal to 5.67 meters per second. We are now in a position to calculate the height of the ceiling, which we will call h, by considering the ball falling from the ceiling to the table. V squared equals u squared plus 2as. V is the speed at which the ball hits the table, which we know is 5.67. As the ball is released from rest, u will be 0, and we will have 2 times 9.8, and this time s will be the height that we are trying to find. Completing this calculation, h is equal to 1.64 meters. I'm now going to measure the height of the ceiling above the table so that we can confirm our values. (173 centimeters). The height that we have measured is greater than the height that we have predicted. This is because of the effects of air resistance on the ball as it moves, and should be expected. A more sophisticated model would take account of the air resistance and would give us a much more realistic model, but would be much harder to deal with mathematically.